This video is going to cover the topic of equivalent ratios. Be sure the date and topic are at the top of your page. The essential question for this video is, how do we determine equivalent ratios? We use equivalent ratios a lot in the world, and they allow us to make generalizations and comparisons about data. Sometimes we want to take our ratios and scale them up, and sometimes we want to use our ratios and scale them down. And as we'll see, when we want to scale something up, we're always going to be sort of thinking about this multiplying idea, right? So we're going to multiply something to scale up our ratio. And conversely, if we want to scale something down, we'll be thinking about division, right? We don't really think about adding or subtracting when we're talking about scaling ratios. We're always talking about multiplying and dividing. This is a ratio I saw recently in the news that said farm workers are often paid about $7 for picking 2 gallons of blueberries. So I'm looking at this as a ratio, and I see that the ratio is 7, in this case $7, for every 2 gallons. So the ratio is 7 to 2. Now we can scale this ratio up and find equivalent ratios. If I double the amount of gallons, I could then double the price or the wages, and the ratio would be 14 to 4, right? Or I could, conversely, instead of doubling it, I could take the value and multiply it by 10 and say, well, if they worked 10 times as long, right, for 20 hours, I would then be able to figure out by multiplying my 7 times 10, I'd be able to see that their wages would be $70, right? So I could scale this up. This is very similar to what we do when we're using a ratio table, right? We're thinking, well, if I adjust one part of my table or one part of my ratio, I have to adjust the other part in the same way. And we can find an infinite number of equivalent ratios when we scale up. So I've just recorded these 3 as examples that these are all equivalent, but we know that there would be many more options. Mr. True often likes to ride his bike, and so we have here a situation where he rode his bike 12 miles in 48 minutes. So the ratio that we're looking at is 12 miles to 48 minutes. And we can use this ratio to scale down to see how far he would go in smaller amounts of time. So for example, I know I could divide 12 and 48 both by 2, and that would mean that he could ride 6 miles in 24 minutes. But I also could divide both of these by 3. And if I divide them both by 3, I'd get another equivalent ratio. 12 divided by 3 is 4, and 48 divided by 3 is 16. So Mr. True could go 4 miles in 16 minutes. I could even divide both of these by 6, and I could say that, well, in 2 miles, it would take him 8 minutes. There are a few other options as well, but all of these are equivalent ratios. Sometimes the equivalent ratio we're looking for is the smallest, most simplified version. For that, the cake method can be really useful. Say, for example, you want to find the most simplified version of the ratio 36 to 30. We can set this up as we used to do with our cake method, and we can think about the values that we can divide both 36 and 30 by. So I'm going ahead and dividing them both by 2. But then I realized they could also be divided again by 3, which leaves me with 6 and 5. This last row here is my most simplified version. So 6 to 5 is equivalent to 36/30ths. Take a look at these 4 ratios that I have. 3 of them are equivalent and 1 is not. So take a moment and decide which of these does not belong. Which one is not equivalent to the other? The one that doesn't belong is, of course, this one, right? All the other ratios are ones that I could get by scaling up or down from the others. For your turn, I want you to determine which of these is not equivalent to the others. For two ratios to be equivalent, it means that both parts of the ratios are changed by either multiplying or dividing by the same value. One of these doesn't fit in with the others. And remember, that was the essential question. How do we determine equivalent ratios? We, of course, will be practicing this more in class. Bring your notes and any questions you might have.